बसवराज गडकरी, बसवराज ऐनापुरे,
Yes, sir.
ओके. भाग्यश्री मठ, भाग्यश्री मठ, भक्ति, भक्ति,
Present, sir.
ओके. भारती,
Present, sir.
राइट. चेतन कुमार, चेतन कुमार, दीपक, दीपक, दिव्या, दिव्या, गढ़ प्रथमेश शिवाजी, गढ़ प्रथमेश शिवाजी, ज्योति, ज्योति, ओके, राइट. किरण लिगाड़े, किरण, लक्ष्मीकांत,
Yes, sir.
ओके. मानतेश, मानतेश,
Yes,
ओके.
sir.
मोले प्रेम,
Present, sir.
राइट. नागेश,
Yes, sir.
ओके. नंदीश,
Present, sir.
नंदीश,
Present,
राइट. पूजा, ओके. पूजा, पूजा. प्रमोद कुमार,
Present, sir.
ओके. प्रमोद कुमार, प्रमोद कुमार. प्रवीण मखदूम, प्रवीण मखदूम. प्रियंका, प्रियंका. संध्या, संध्या. संतोष पुजारी, संतोष पुजारी. संतोष सोनार, संतोष सोनार. शाहबाज,
Yes, sir.
ओके. शफिया,
Present, sir.
राइट. श्रीधर सोलकनावर,
Yes, sir.
ओके. सृष्टि,
Present, sir.
राइट. सिद्धार्थ वर्णेकर, सिद्धार्थ वर्णेकर. सिद्धार्थ पाटिल, सिद्धार्थ पाटिल. सुप्रिया,
Present, sir.
राइट, राइट. वंदना, वंदना,
Present, sir.
ओके. म्यूट योर सेल फोन्स. वसंत, वसंत. वेददत्ता, वेददत्ता. योगेश,
Yes, sir.
ओके. महेश,
Yes, sir.
राइट. बालेश, बालेश. तैक मोहम्मद,
Yes, sir.
राइट. प्रवीण राठौड़. अभिषेक,
Present, sir.
राइट. ऐश्वर्या, ऐश्वर्या. अमानुल्ला, अमानुल्ला. बंडोडकर तनय मोहनदास, बंडोडकर तनय मोहनदास. भावराव, भावराव. शोधन,
Present, sir.
भावराव. शोधन,
Present, sir.
ओके.
Bauram More.
प्रेजेंट, यस.
Okay, sir.
मार्क. देवಣ್ಣवर अनिल कुमार शेकप्ಪ, देवಣ್ಣवर अनिल कुमार शेकप्ಪ. नंद कुमार, नंद कुमार. प्रमोद केस्ती, प्रमोद केस्ती. रोहिणी,
Present, sir.
राइट. रोहित अलवाणी,
Present, sir.
राइट. शशिधर, शशिधर. Sridhar. Sridhar.
Present, sir. Present, sir.
Right. Okay. Saish. Saish. Snehal. Snehal. Vaishnavi. Vaishnavi. Karthikyam. Karthikyam. Okay. Anybody joined late? Anybody joined late?
Sir, Kiran Ligadi.
Sir,
Kiran
Vasant.
Ligade. One ನಿಮಿಷ ರೀ. ಕಿರಣ್ ಲಿಗಾಡೆ ರೋಲ್ ನಂಬರ್ ಎಷ್ಟ್ರಿ ಕಿರಣ್?
Sir, 17th.
17. Okay. Anybody else?
Vasant, sir.
Vasant, I have marked. Okay. Anybody else?
Sir, Chetan.
Bhavra, I have marked. Chetan, what is your roll number?
Sir, 11.
11. I have marked. Okay. Fine. Anybody else? Okay.
Sir, Pooja Patil.
Pooja Patel, I have marked. I have marked. Okay. So, any doubts in the assignment questions, students? Any doubts in the assignment questions? So, first question is clear. Are you able to see the screen here? Students, are you able to see the screen?
Yes, sir. Yes, sir.
Okay. The first question is clear. Give the block diagram of microprocessor and microcontroller and justify that microcontroller is a true computer on a chip. Okay, you have to tell, first you have to draw the block diagram of microprocessor and microcontroller. Okay, after drawing the block diagram, right, you have to explain them, and then you have to tell why microcontroller is called as true computer on a chip. Because all the components are present on a single chip, that is RAM, ROM, IO port, timer, serial COM port. Okay, all are present on a single chip, and hence microcontroller is called as true computer on a chip. Okay, like that you have to write here. Okay, that is the first question. Second question, direct question, it is compare microprocessor and microcontrollers. So you have to compare microprocessor with microcontroller, write the features of microprocessor and compare the similar kind of features with that of microcontrollers, right? That is comparison between microprocessor and microcontrollers. And distinguish, question number 3, distinguish the different types of microcontrollers. So in this, you can write in the various ways. You can write, one is, you can give the comparison as the RISC and CISC. Then you can give the comparison as Princeton and von Neumann, Princeton or von Neumann architecture and Harvard architecture. And another way of explaining this is write the differences between 8031, 8051 and 8052. Okay, so you have to write the differences between 8031, 8051 and 8052. That is available in the Majidi that this I have provided. Okay, PDF I have provided, just refer to that. Okay, so you'll get the comparison between the 3 types of microcontrollers, that is 8031, 8051 and 8052. Okay, in 8031, how much is the RAM memory? In 8051, how much is the RAM memory? In 8052, how much is the RAM memory? Okay, how much is ROM memory size in 8031? How much is ROM memory size in 8051? And how much is the ROM memory size in 8052? Like that, the comparison is given. Just refer to that. Okay, you will understand the differences between the different types of microcontrollers. That is 8031, 8051, and 8052. Next question. What is Harvard architecture? Show that 8051 uses Harvard architecture. First, you have to explain Harvard architecture. So in Harvard architecture, the program memory and data memory are separate. Okay, you have to draw the block diagram and then you have to explain that there is a separate program memory and data memory, then explain its advantages. So if program memory and data memory are separate, the fetching of data will be simultaneous and hence the speed of accessing of data is very much faster in case of Harvard architecture as compared to that of the Princeton architecture. Okay, so explain few points about the Harvard architecture, see the marks and then explain. Okay, and then you have to tell that how should 8051 uses Harvard architecture. That means you have to draw the Harvard architecture of the 8051 microcontroller and tell that because it is having different program memory and data memory, and hence the 8051 uses Harvard architecture. Like that you have to draw the this thing here, points here. Okay, first you have to explain what is Harvard architecture, then draw the block diagram of 8051 Harvard architecture, and then say that as it is using different program memory and data memory, so because of that the Harvard it is called as the Harvard architecture, or the 8051 microcontroller makes use of the Harvard architecture, right? So in that way you have to explain. Okay, to cover up all the features of Harvard architecture. Okay, all the features of Harvard architecture you have to write, and then you have to explain, because it may be asked for 7 marks or 8 marks question. So you have to cover the features and then you have to explain it. Okay, next, explain the differences between Harvard and von Neumann architecture. Then you have to explain the differences. This is a comparison between Harvard and von Neumann. In examination also, 2 questions will be compulsory on comparison of, they may ask comparison of microprocessor with microcontroller, or comparison with RISC and CISC, or comparison between Princeton and Harvard architecture. Okay, so any of these comparisons is sure questions in the examination. Make them perfect. All the comparisons whatever are there in your syllabus, make them perfect. In examination there will be sure questions on this comparison part. The next is explain the differences between RISC and CISC. So difference between Harvard and von Neumann architecture is you have to explain that Harvard architecture has program memory and data memory separate, whereas in Princeton program and data memory are the single block of memory. It's the same block of memory which is used as program memory and data memory in von Neumann architecture. Right? Then Harvard architecture is faster, von Neumann architecture is slower to access the data. So like that you have to explain all the features of Harvard architecture and all the features of von Neumann architecture. You have to write the comparison. You have to write it. You can draw a line in between. One first column you can take it as Harvard, and second column von Neumann, or first column Princeton, second column Harvard, whatever it is, and then make the comparison point by point. First comparison, second comparison here in Harvard, second comparison there in von Neumann, third comparison in Harvard, third comparison in von Neumann, like that. Okay. Then similarly, question number 6, explain the differences between RISC and CISC. Again, you have to draw the column there, and then in first column RISC, in the second column CISC, explain the features of RISC and then compare those features of RISC with that of the CISC. Okay. Then next, list the salient features of 8051 microcontroller. Salient features is you have to explain the important features. Like for example, it has 128 byte of RAM memory, 4 kilobytes of ROM memory, 16-bit program counter and DPTR registers. So all those features you have to write them. Okay, they have asked just to list the features. In examination, if they ask to explain, see the marks and write. If they're asking only list the silent features, and if they ask for just 5 marks or 4 marks, you have to just list the features. The same question is asked for list and explain the silent features of 8051 microcontroller. Then you have to write all the silent features first, and then go on explaining each silent feature one after the another. Okay, so like that you have to cover up the question based on the marks. So you have to always see the marks and then write your answers. Next question, with the neat block diagram, explain the internal architecture of 8051 microcontroller. So internal architecture is nothing but the block diagram. It is the block diagram or internal architecture, both are one and the same. You have to draw the block diagram, draw it neatly, draw neat block diagram. Okay, consisting of the features such as ROM, RAM, timer, serial COM port, CPU, okay, A and B registers. Draw the complete block diagram, and based on that block diagram, you go on explaining the various blocks of the microcontroller architecture. Okay, what is RAM? Okay, what are its features? What is ROM? What are its features? Right? Then what is CPU? Right? So all those features. What is timer? Okay, what is the difference between timer? Timer is used as a timer and also as a counter. So you have to write a timer as a timer and timer as a counter. So all those different blocks you have to explain them. Next, question number 9, explain the pin diagram of 8051 microcontroller. How many pin 8051 microcontroller is? 8051 microcontroller has how many pins? IC?
40
pin IC. It is a 40 pin IC. Among the 40 pins, the 32 pins are of the ports only. 32 pins are for the ports. There are 4 ports, P0, P1, P2 and P3. So each port has got 8 pins, IO pins, So 8 into 4, 32 pins will be for the port pins only. Remaining pins are for TXT, RXT. Okay, port 1 is a dedicated port. Other ports, okay, so for example, if you consider port 3, it has having dual functions. Dual functions. That means it is used as an input-output port, and also it has got some alternative functions also, like for transmitting the data, for receiving the data into the microcontroller, TXD, RXD. Okay, so all those you have to draw the pin diagram, the chip 8051 microcontroller pin diagram, and then explain the various pins of the 8051 microcontroller, various pins of the 8051 microcontroller, one after the another. Go step by step and see that you cover up all the pins of the 8051 microcontroller. Next, explain the special function registers of 8051 microcontroller. So these special function registers you have to cover. A register is there, B register is there, PSW register, DPTR register, TMOD, SCON, PCON. Okay, all these special function registers you have to explain them. What are the different special function registers? First, first you have to define special function register, then list the special function registers and go on explaining one after the another. Okay. Then question number 11, explain the memory organization of 8051 microcontroller. Memory organization means you have to cover up here the RAM memory organization and also the ROM memory organization. Okay, so that block diagram I have given in my notes, it covers both the internal memory and external memory, both RAM memory as well as ROM memory. You have to cover up all these details. Internal memory and external memory, then RAM memory and the ROM memory. Okay, it should come both the memory organization of 8051, how is the memory organized for the ROM memory, and how is the memory organization of the RAM memory. So it should cover up all the details of the total RAM and ROM memory organization of 8051 microcontroller. Next, what is stack? Explain with examples the push and pop instructions. Stack memory, we know that. Okay, how it works. So stack is last in first out memory, right? Okay, this stack memory you have to explain considering few examples of the push and pop instructions. Okay, whenever you are using push, the data will be pushed into the stack memory. You are storing the data into the stack memory. When you use the pop instruction, you are reading the value from the stack memory. You are reading the value from the stack memory into the register. Okay, so that concept you have to explain considering the push and pop instructions. You know that concept. Okay, when pushing the data, it will increment the memory location first and then it will store the data. When popping the data, it will read the value first from the stack memory and then it will decrement the memory location. Okay, so that concept you have to explain. So interface 16K EEPROM, this question I told that I will be covering later. Okay, this is in module 5 it comes, so we can leave this part. Then explain the addressing modes of 8051 with example for each. Various addressing modes. So we know that addressing mode is the one which explains how the data is stored in the registers and in the memory location. Then the various addressing modes, there are about 7 to 8 addressing modes. You have to list them first. Immediate addressing mode, register, register indirect. Okay. Then the implicit addressing mode. Okay. Then next one, indexed addressing mode, absolute addressing mode, long addressing mode. All those 7 to 8 addressing modes, you have to list them and you have to explain them considering examples. Note that whenever you are explaining anything, okay, it should be always with the examples, with instructions, with examples. Okay, because those will carry marks. And when you explain with examples, the evaluator, one who checks your answer paper, will come to know that you understood the concept. So that is the reason you have to always consider the examples and then you have to explain that concept, or it may be some instruction, or it may be addressing mode. Okay, whatever it may be, you have to consider the examples and then you have to explain that particular part of the question or particular part of the concept. Okay, that particular concept should be explained always by considering the examples. Next, write an assembly program to copy the value 55H into RAM memory locations 40H to 45H. This assembly program I have explained in the class, okay, in yesterday's class, that I have explained how to copy 55H value into RAM memory locations 40H to 45H using direct addressing mode, register indirect addressing mode, and with the loop. Okay, so that is I have explained. Write an assembly program to clear 16 RAM locations starting at address 60H, RAM address 60H. This also I have explained how to clear 16 RAM locations starting at RAM address 60H. Then next, take 10 bytes of data from data RAM locations 45 to 54H, add 2 to each of them, and save the result in data RAM location 79H down to 70H. Okay, this program is similar to the program that I explained, that is copy 10 bytes of data from particular memory location to some other memory location. So it is similar to that program. Almost all instructions are same, only you have to use the add instruction. Okay, you have to, when you get the value from 45H to, say what they are asking to transfer take 10 bytes of data from RAM locations 45H to 54H. Okay, first you have to get the value, say from 45H you are getting the value. Okay, you are using the same instruction as we did for that program. Then just you have to use this add instruction, that will come extra. Only this instruction will come extra, add 02 to that value, and then you have to transfer this value from 45 to 79. That's all. Okay, you have to transfer that value, whatever you are getting after adding to that value, you have to transfer. Now, when we explained that program, what we did, we directly transferred the value from 45 to 79 or whatever the memory locations was there. Now, what you have to do, first you have to get the value from 45, just you have to add that value, add 02 to that value, and then you have to transfer the result to 79H memory location. Clear here? So that is how you are supposed to do it here. The rest of the instructions, all instructions are same, except you have to make use of add that 02 add instruction or add with carry instruction you have to make use of, and then write the remaining instructions same. Okay. Question number 18, write an assembly program to get the X value from P1 and send X square to P2 continuously. You have to read the value from X, okay, read the X value from P1 and then send X square to P2 continuously, send X square to P2 continuously. This program we solved in yesterday's class. I explained to you all how to get the value of X from P1, make P1 as the input port, and then send the X square value to P2, make P2 as the output port. And write an assembly program to store 10 terms of Fibonacci series. 10 terms of Fibonacci series. Okay. So how will you do this? 10 terms. What is a Fibonacci series? What is a Fibonacci series? Yes. Can anybody tell me? What is a Fibonacci series?
Next term will be sum of previous two terms.
Yes, correct. You are right. Exactly. The next two terms will be sum of previous two terms. Okay. Has anybody done that program? Has anybody written that? To store 10 numbers or to get the 10 numbers. Has anybody done that? Yes. Has anybody done that? Has anybody done that program? To store 10 terms of Fibonacci series. In the recent question paper, they have asked this, write an assembly program to store 10 terms of Fibonacci series. Has anybody written the program for this? Have you tried it out? This program?
No, sir.
Yes? No? See here. So first, I will be using the instruction to store the starting memory location. Move R0, hash 50H. Hash 50H. Okay. Move R0, hash 50H. R0 is R0. Right. So in R0, let us say I have taken the values. I have stored the values starting from memory location 50H. Okay. Starting from memory location 50H, I have stored the values. Okay. So in 50H, let us say that you have stored all the different values in 50H. I have stored, say, first number 01. Okay. Next 51H will be 02. In 52H, some of these two I have stored in 52H. Okay. I have stored in, say, that is 01 plus 02, that is 03. I have stored in 52H. Then in 53H, sum of the previous two. Okay, 1 plus 2 is 3 we are getting. Okay. Then 2 plus 3, 53H. That I am storing in plus 3. Okay. That I am storing in 53H, like that. Okay. So move R0 comma hash 50H. So like this I have stored 10 numbers, right? Move R0 comma hash 50H. Then I'll use the count move R7 comma hash 09. Count value I'll take hash 09. Okay. Then next count I'm taking 9 because when you are adding two numbers at a time, there will be remaining only. First example, you are adding 1 with 2. Okay. When we add 1 with 2, right? So what we are doing here? What is the logic here? 01 plus 02, that is equal to 03. 1 plus 02, that is equal to 03, right? Then next, what we are doing? 01 plus 02 is equal to 03. Once we get 03, okay, 2 plus 3, 2 plus 3, 1 plus 2 is 3. Okay. So the previous two numbers we are adding, then to get the next number. So 1 plus 2 is 3, then next is 3 plus 2. 3 plus 2. 3 plus 2. That will give us 5. Okay. Which is the previous number 1, 2, 3. 1 plus 2 is 3. 3 plus 2 is 5. Then previous number is 3 we have taken. Okay. So that will give us 5 plus 3. 5 plus 3 is equal to 8. Okay. 5 plus 3 is equal to 8. Plus 3 is equal to 5. 2 plus 3 is equal to 5. Okay. Then 3 plus 5, previous number is 3. 3 plus 5 is equal to 8. Okay. And next, 5 plus 8. 5 plus 8 equal to 13. Okay, this is the logic, right? So 1 plus 2, we are adding 1 with 2. First we have taken the first number as 1. First number as 1. First number as 1 here. 0, 1. Then 0, 2 we have taken. So 0, 1 plus 0, 2 will be 3. Right? 0, 2 plus 0, 3 will be 0, 5. 0, 3 plus 0, 5 will be 0, 8. 0, 5 plus 0, 8 will be 13. Like this. This is how we are doing it. The sum of 3. Yes, please.
Sir, that 18 how comes?
18 is not there. 8 it is. Sorry. This is not 18. This is 8. Sorry. Thank you. So 5 plus 8 is 13 it is.
Okay,
Correct, no? 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Okay. So now we got the move R0 comma hash 50H. We got it here. So let us write it here. 01 plus 02 is 03. 02 plus 03 is 05. 03 plus 05 is 07. 2 plus 3 is 8. 5. 03 plus 5 is 8. 5 plus 8 is 13. Let us write few numbers here. Move R0 comma hash 50H. Then move R7 comma hash. When you are adding two numbers here at a time, so remaining numbers will be 2 numbers, that is 8 numbers will remain. They have asked to add first 10 numbers to store the first 10 series of the Fibonacci series. So when you are adding first 2 numbers, right, first 2 numbers when you are adding, so remaining how many numbers will remain? 8 numbers, correct? So that is why we have to take the count as 9 here, 1 less than 10. You should not take it as 10. Okay, then take the first value, move a comma at r0, right, move a comma at r0. What will be the value in a? So r0 value is 50h. Let us write them. r0 is equal to 50h. In 50h memory location we have stored the values. In 50h memory location we have stored the values here. Then r7 is r7, it is 9. Okay, so r7 equal to 09. Then next, move a comma at r0. So move a comma at r0 means value in a will consist of the value in 50h memory location. So value in 50h is first value, that is 01. Okay, we got the first value. Increment r0. Increment r0. So what will be the value in r0? R0 will be equal to 50h plus 1. 50h plus 1, that is 51h. Okay, so we got it as 51h. Next memory location. Now what I will do is I will move the value in a. Move a comma at r0 means first value has come. So I will move the value in a register to some other register. Move r5 comma a. Move r5 comma a. Move r5 comma a. So that will give me r0 equal to, sorry, r5 is equal to a. R5 is equal to a. What is the value in a? We have got 1, so it is 1. In r5 I am storing 1 there, right? Then next, move. So I got, now where is my 1? First value I have stored in r5. Okay, then what I am doing, move a comma at r0. Move a comma at r0. Move a comma at r0 means what is the r0? Recent memory location 51h. Okay, so the value in a will be value in 51h memory location. Value in 51h memory location, that will be how much? Value in 51h is how much? 51h we have taken 2, correct? So it is 02. Okay, so 02 will come and it will get stored in a. Next we have to use ADDC a comma r5. A comma r5. If you use this, then you will get the value in a will be equal to value in a plus r5 plus r5. What is the value in a we got? It is the value in a is 2 now. 2. Second value, it is getting added with the first value. First value in r5 it is 1. So 2 plus 1, we got it as 3. Okay. Next we have to add 2 to 3, right? 2 to 3 we have to add. So we got it here, ADDC. Then next what I will do is, so we got that 2 in A register. Okay, so from A, now it is in 51. Okay, in 51 it is, we have the value, that is 2 is there. Okay, so in 51h already 2 is there, right? Then now 3 we got this. Then next what we will do is increment r0, increment r0. So r0 will be equal to, now what will be the r0 here? 50. Previous location in r0, just check it. What is the previous location in r0? 51h. See here, this one, 51h, right? This is 51h. So now it is 51h plus 1. 51h plus 1, it is 52h. Okay. So now next what we have to do is, we have to add the value 2 with 3, 2 with 3. Okay, 1 and 2 we got 3. Next we have to add this value with this value. Okay, so to add this value with this value, what we have to do here, a value is how much? 2. Now a value is 3. Okay, a value is 3. Okay, a value is 3. Then we have to get the previous memory location. What is the recent memory location now? Recent memory location is R0 is how much? 51H. So it is 2. Okay, so 2 in R0 should be, that is 2 is there in 51H now. In 51H we have 2. Okay, so then in 51H whatever is 2, that we have to add with again the value that is 3. Okay, 3 is there in A register now. Okay, so this 3 which is in there in A register, move that into some other register. Move R R3 comma A. Move R3 comma A. In R3 the value that I got is, the value in R3 is equal to A, that is equal to R3 is equal to A, so that is equal to how much? 3. Okay, here I got. Okay, then next what I have to do is I have to add this E to this 3, I have to add it to 2. Correct. So next, where is that 2 there? 2 is there in R0. Okay, 2 is there in R0. So I have not incremented still, it is 51H only. So now next what I will do, add with carry. So this carry. Okay, add with carry A value is 3, A comma at R0, A comma at R0, at R0. What this instruction will do, the value in A will be value in A plus the value in R0. Value in R0 is which memory location? Still just check the recent memory location R0, it is 51H. I have marked here. Okay, this one R0 is equal to 51H. So at R0 means next what it will do, value in R0 is 51H memory location. So this will be what? Value in A is P here, P plus value in 51H, that is 2. That will be 5. So we got it as 5. Okay. Now plus 3 plus 2 we got it as 5. So similarly we have to add now. Next is we have to add 3 plus 5. Okay, where is this 3? That is in A I have got 5. In A I have got 5. Okay, this 5 I have to add with 3. Okay, so this 1 plus 2 is 3. 3 plus 2 is 5. Next is the next sequence. 3 plus 2 is 5. Okay, 1 plus 2, 3 we got 5 now. Now 3 plus 5 we have to do. This one here. 3 plus 5. These two I have to add. 3 plus 5. Where is 3? Where is 5? Just see there. So 3 I have stored in R3. Okay, 3 I have stored in R3, right? Then so 3 plus 5, so 3 is there in R3, so that I have to add with 5 here, add with 5. Okay, so if I want to add that 3 plus 5 here, then I have to use the back instruction. Okay, back instruction. So if I want to add that, so move R3 comma A, 3 is there, 3 plus 5 I have to do. So 3 plus 5 is 8. 3 plus 5 is 8. Okay, so I'll use the instruction short jump to back, short jump to back, jump to back here. Okay. So the way this back should come, now we have to add 3 with 5. Okay, so Next is back comes here. If back comes here, so that is R3 comma A will be having 3 there. Then ADDC A comma at R0. So before this, I have to increment the memory location. Increment. So in 51H, that is 5 I got. Okay. So R3 we have 3. Then that I have to add to here. Okay. So here if I use the instruction 3 plus 5 I want now. So 5 is there in A. In A it is 5. In R3 it is 3. Okay. Next I will add 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 with carry A comma that is A comma then 3 plus 5. Okay, A is 5, then R3 is 3. So what we get here, that is A is equal to A plus 3. So this will be value in A is 5, then plus 3. So that will be 8. Okay, so like this you have to go on writing the instructions. It will take hardly 3 or 4 more instructions, because we are adding only first 10 numbers. Now already how many numbers we got? 1 plus 2 plus 3 plus 5, 8 we got already. Already we got 5 numbers. So another 2 to 3 instructions it will take to get the next instructions. Okay. So this is how you are supposed to add them. Then with the loop also you can do that.
Sir,
Okay.
loop ಆಗ್ಬೋದಲ್ಲ sir?
ಕಳಿಸ್ಕೊಡ್ತೇನೆ ನಿಮ್ಗೆ ಸೊಲ್ಯೂಷನ್ ಕಳಿಸ್ಕೊಡ್ತೇನೆ ಲೂಪ್ ಹಾಕಿದ್ದ. I'll send the solution to you. Okay, I'll just share with you, right? Sandesh, ಆ ಸೊಲ್ಯೂಷನ್ ಶೇರ್ ಮಾಡ್ತೇನೆ ನಿಮ್ಗೆ.
ಹಾ ಸರ್
ಕಳಿಸ್ಕೊಡ್ತೇನ್ರಿ. ಇದ ವಿದೌಟ್ ಲೂಪ್ ಮಾಡೋದ್ರಿ ಇದ. ಸೊ ವಿತ್ ಲೂಪ್ ಏನೈತಲ್ಲ ನಿಮ್ಗೆ ಸೊಲ್ಯೂಷನ್ ಸ್ವಲ್ಪ ಕಳಿಸ್ಕೊಡ್ತೇನೆ ನಾನು. ಶೇರ್ ಮಾಡ್ತೀನಿ, ಇವತ್ತು ಮಧ್ಯಾಹ್ನ ತನಕ ಶೇರ್ ಮಾಡ್ತೇನೆ. ಓಕೆ
ಸರಿ ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಓಕೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ನೋಡ್ರಿ, ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಮತ್ತೇನ್ ಡೌಟ್ ಅದಾವನ್ರಿ? ಎವರೇಜ್ ನಂಬರ್ ಮಾಡ್ಬೋದಲ್ಲ? Average of program to find average of 10 numbers. So first you have to take the sum of 10 numbers and then divide by total number of numbers. You know how to do that. Average number heng ಮಾಡ್ತೀರಿ? move R7 hash 10 numbers ತಗೊಳ್ರಿ. Okay, move A hash 00H. Okay, first sum is you are initializing it as 0. Correct? Sum you are initializing it as 0. Then R0 hash 50H. Starting memory location ತಗೊಳ್ರಿ. Then use the instruction ADDC A at R0. ADDC A at R0. Increment R0. Simple ಐತ್ರಿ. ಇಲ್ಲಿ ನೋಡ್ರಿ, average of 10 numbers. Move R7 hash 10. Okay. Then move A hash 00H. Move A hash 00H. Move R0 hash 50H, starting memory location where the different 10 numbers are stored is from 50H. Then you are using the loop here. I'll tell you that. Before using the loop, let us write the instruction ADDC A at R0. ADDC A at R0. Then increment R0 to get the next instruction to next value. To get the next value, increment R0. Okay. Then DJNZ the count. DJNZ R7 again. R7 again. Okay, so it will add the first value 0. It will add first with the value in first memory location 50H. Okay. That will be stored in A. Then increment R0, you will get 51H. Right. So if 51H, then DJNZ R7. R7 is how much? 10 we have taken. So 10 minus 1 is 9. So if it is not 0, it will jump to again. So where this again should come? So this again should come to ADDC here. again should come here, ADDC A comma at R0, ADDC A comma at R0. Okay, then increment R0, so it will add the value in A with next memory location because we have incremented here. Okay, so value in A will be added with the value in next memory location, that is third memory location, second memory location. First we are adding 0 with the value in 50H, then we are adding value in A with the value in 51H because we are incrementing here, incrementing R0. Okay, then DJNZ R7, that is 10 minus 1 9, so still 9 numbers are remaining. If it is not 0, it will jump to again it will perform ADDC A comma at R0. Now after this step, suppose if it comes out here, what will be there in A? A will have the sum, total value, sum of all the 10 numbers. Now we want the average. So if you want the average, then what we have to do here is, so move A comma hash 0 0 we have done. Okay, then move count value we have stored in, count value not taken here, count value you have to take. So that is move R7 comma hash 10, R7 comma hash 10. Then we can use move A comma R7. 1 minute, move R7 comma hash 10. Move A comma R7, move A comma R7. Then next instruction you can use move B comma R7, move B comma R7. Okay, move B comma R7. Right. So the value in A, that is 10, which will come in A, from A it will move to B. Okay, so the recent value in B will be 10. Okay, then once it is 10 here, so this instruction you can use later. Okay, this instruction you can use it later after this instruction because it will get initialized to 0. If you are using storing 10 there, it will be 10 only there. Then you can use move A comma hash 00H, hash 00H. Okay, so B value is 10. So after getting the total value, then what you have to do? Divide A by B. DIV, divide A by B. So the value in A will be divided by the value in B. That is total sum divided by total number of values, 10 values. Then the result, what you can do is you can store it in some register. Move R5 comma A. Move R5 comma A. Then end the program. It's a simple program. You first find the sum of all the numbers. Then after you come out of the loop, divide the value in A by the total number of values. So that will give you the average of all the values. Store that result in some of the registers, in any of the registers. Clear here? This is clear here? Okay. This is for average. Then this is related to program status word register. You have to draw the program status word register and you have to explain the different bits. Write the steps to create a program. That is assembling and running an 8051 program. You have to write the steps there. Explain the assembler directives of 8051 microcontroller with examples for each. It is a direct question. Use assembler directives to place constants 0FCH, 05H, 76H, 28D and character string SIM. This is a very simple program. Just it's a 2 to 3 line program. Start from 0050H. Okay. So here, say you are storing he has given some constant. They have given some constants there. So they have asked to start from org 0050H. Then you have to use say constant colon define byte. That is you have to use the assembler directive. And whatever values they have given, you have to just store them. They are asking to just store those values. Store those values. What are the values given? FC 05 76 28, FC 06 28. So like this, you have to store the values. And one more they have given is to store the character string. Okay. Character string also you can store. SAM something they have given, SAM. So that also you can store using the DB directive, defined by directive. Okay. Then end the program. End it. Okay. That's all it is. It's a hardly 2 to 3 line assembler directive, but you have to do it with assembler directives. Okay. Then add the numbers 56H and 95H and show how the carry flag, auxiliary carry flag, and parity flags are affected. This we have seen when we are discussing in the class. We added 56 with 95. Whatever result you are getting, that result you have to check whether the carry is generated or auxiliary carry is 1 or parity is 1. Okay, so carry is 1 means that particular bit you have to see, that particular bit in that bit structure, 8-bit programs to test word register. If that is 1, then carry flag will be 1. Auxiliary carry flag, similarly you have to check that. And parity flag, if there are even number of ones, then it is parity is 1. If there are odd number of ones, parity is 0. Okay, so like this you have to check. We have taken many examples and solved when we are discussing about the various types of flags. Okay, so this is how you are supposed to, I mean, this is about the assignment questions here. Anything you want to ask here? Anything you want to ask? Any doubts here?
Sir,
Yes.
sir, in 20th question, why should we take that R7?
ಯಾವ question ರೀ?
20th?
20th question ರೀ? One ನಿಮಿಷ.
Yes, sir.
R7 ತಗೋಬೇಕಂತ ಏನಿಲ್ಲ, ಡೈರೆಕ್ಟ್ ನೀವು A, B ನು ಮಾಡಬಹುದ್ರಿ ಅಲ್ಲಿ, ಅಥವಾ B, ಏನು ಮಾಡಬಹುದು ನೀವು ಅಲ್ಲಿ. A ವ್ಯಾಲ್ಯೂ ಒಳಗ್ರಿ ನೀವು 10 ಸ್ಟೋರ್ ಮಾಡ್ಕೊಂಡ್ರಿ, ಅದನ್ನ ಮೂವ್ B, A ಮಾಡಿದ್ರು ನಡೀತೈತೆ. R7 ನಾಟ್ ನೆಸೆಸರಿ ದೇರ್. ಓಕೆ ಶಾಬಾಸ್.
Yes, sir.
R7 ನೆಸೆಸರಿ ಇಲ್ರಿ ಅಲ್ಲಿ, ಮೂವ್ B, A ಮಾಡಿದ್ರು ನಡೀತೈತೆ ಡೈರೆಕ್ಟ್ಲಿ. Okay.
Yes, sir.
Anything else you want to ask? Anybody?
No.
Okay. Then we'll wind up the session here. All the best for your test. Do well.